In calculating the volume of solids of revolution using washer method, we saw that if we have an object and start rotating that object around x-axis, we are basically creating this solid. And if you look at the cross-section, the cross-section is nothing but a washer. So for a washer, to calculate the area, you have a larger area and you have a smaller area. You calculate those areas and do the subtraction, then you plug those into the definite integral, take the definite integral. So V is equal to the pi, the definite integral of larger radius to the second power minus the smaller radius to the second power dx. If radius is associated to a function, larger radius is associated to function f, you plug f of x and raise it to the second power. And if you have the smaller radius associated to function g, you plug in g and raise it to the second power and do the calculation. But please note that we are rotating the object with respect to x-axis. Expect you to ask, what if we rotate the object with respect to y-axis? Do we have a different formula? Basically, sometimes it's easier to do the calculation following the formula. For example, if you take the object and rotate the object with respect to y-axis, we expect the shape to be like this. And as you can see, here you have your washer. The idea is the same. You're going to calculate the area of the washer by subtracting the smaller area from the larger area. But now you need to write everything in terms of y. So the volume is the definite integral of the larger area, which is pi of ry to the second power minus ry to the second power. So this capital R representing the larger area, larger radius, and this smaller r shows the smaller radius. Let's take a look at one example together. In this question, the region bounded by parabola y equals to x squared and the line y equals to 2x is located in the first quadrant, and it's revolved about the y-axis to generate a solid. Our goal is to find the volume of that solid. So let us begin. Let us visualize this. Y equals to x squared is piece of parabola here, and since it's located in the first quadrant, we look at this piece. And then y equals to 2x is this increasing line. In the first quadrant, they're intersecting at the origin and 2 and 4. We're going to rotate this about y-axis. So we're going to rewrite these two functions. Y equals to 2x can be written as x equals to y divided by 2. And y equals to x squared can be written as x equals to square root of y. Now, in terms of radius, because we're going to rotate this guy with respect to y-axis, and then you have your cross-section, which is a washer. But to calculate this little piece here, the larger radius is square root of y, or the larger distance between this region and the y-axis is square root of y, and the smaller radius or the smaller distance is the distance between this point or this graph to y-axis, which is y divided by 2. Now, if we start rotating this object with respect to y-axis, this is the solid that we are getting. As you can see, the cross-section of this solid is a washer. Our goal is to calculate the area of this washer and then take the definite integral. So let us begin. The question, the visualization, and the formula that we are using to calculate the volume of the solid rotated about y-axis. This is the definite integral c to d pi ry to the second power, which is basically your larger radius minus ry to the second power, and this is your smaller radius. Then you take the integral with respect to y. This is equal to the definite integral 0 to 4. This is the range for your y value. If you set 2x and x squared equal to each other and bring 2x to the other side, factor out x, get x times x minus 2 equal to 0, and you have one intersection at 2. When x is equal to 2, your y value becomes 4. That's how you know where to stop. So the boundary is 0 to 4, plug in pi, and the larger radius is square root of y, but you need to raise it to the second power to follow the area formula. Minus the smaller radius, which is y divided by 2. And then you take the integral with respect to y. We can simplify this further. Here you have pi, the definite integral 0 to 4. The square root of y squared is just y. And y divided by 2 to the second power is y squared divided by 4. Then you take the integral with respect to y. Now we are going back to basic integration formulas. The integral of u to power n du is u to power n plus 1 divided by n plus 1 plus constant of integration. But since you have upper bound and lower bound, you just need to plug those in. So this is equal to I, the integral of y dy is y squared divided by 2. And the integral of y squared divided by 4 is y cubed divided by 3 times 4, which is 12. Then you plug in 4, then you plug in 0, and do the subtraction, and you get 8/3 pi. This is the volume of this solid. So again, let me write this guy down for you here. How do you get this 4? To get this 4, set x squared equals to 2x. Bring 2x to the other side. You get x squared minus 2x equal to 0. Solving this equation, you get two x values. One x is 0, and the other x is 2. But please note that we are not finding the boundary for our x. We are finding the boundary for our y. We use x to find those y values. So when x is equal to 2, if you plug that in to one of the functions, when x is equal to 2, your y, one of the y values, you're finding the intersection. So it doesn't matter which one you're using. Your y becomes 4. So that's how you end up with this 4 as the upper bound of your y value.